So today we're going to review what you already know about graphing a parabola, and I'm going to introduce some new information to you. So what we're going to do today is focus on looking at an equation and in its different forms, and then identifying what immediately is revealed to us just from the form of the equation. So we're going to start off with the three major forms of the quadratic equation. You are all familiar with standard form. We spent last semester working on it a great deal. Of course, you can't see it because it's not on the screen, but it shows on my screen. So my students that are watching the video can see. There we go. Okay, so standard form. Y equals ax squared plus bx plus c. Okay, when I look at standard form, I immediately identify two things that I need to know for my graph. Immediately. I've trained myself to look for them, identify them, and go straight to the graph and graph them. Okay, do you remember? Or I probably should review. Yeah, remind you? Okay, so that's standard form. You're familiar with it. You know how to factor it. You know how to find the zeros. You know how to do that. The second form is intercept form, or other words, factored form. Some professors and teachers will call it factored form. Okay, so it looks like this. A times the quantity of x minus some number p times the quantity x minus some number q. Okay, it's the factored form. It immediately reveals two things. Well, three things, actually. Okay, and then vertex form, my favorite form, because it helps me get to my graph. I graph my vertex, I look at my A term, and I graph my points, and I'm finished, and I move on. So my favorite form, of course, is vertex form, because it gives me enough information to just go splat. There's my graph, moving on. Okay, it gives you two pieces of information immediately if you know how to identify that information. So what we're going to do is we're going to take these three equations that I have provided for you, and we are going to identify what each one reveals on the graph. All three of these equations, equation 1, f of x equals x squared plus 6x plus 8. Equation 2, f of x equals quantity x plus 2 times quantity x plus 4. And 3, f of x equals x plus 3 quantity squared minus 1, are all represented in this graph. They're all exactly the same equation, written in different forms. So when I look at my first equation here, I always look at my A term. In this case, my A term is 1. And so when A equals a positive number, this immediately tells me that my parabola is going to go up forever. So that's useful information when I'm going to a graph. It also immediately reveals to me something quite simple. If I plug in zeros, which are easiest things to plug in, you know, I get 0 squared plus 6 times 0 plus 8. Correct? So the f of 0 is 8. This reveals to me this point, 0, 8. And if I go over here to my graph at 0, 8, I have a point. This point is called the Y-intercept. And I immediately recognize it as such, because I can visually, or in my head, plug in zeros for x, which cancels out your A term and your B term, leaving you with your C term, which is your Y-intercept. I appreciate standard form because it provides me with that information. Okay, the next one is factored form or intercept form. And it provides for me, first of all, my A is also 1. There's an A right there, and it's a 1. And so I know that since my A is positive, this parabola opens up. It reveals that same set of information as the first one. But it also reveals to me something you guys are very familiar with. When my y equals 0, remember f of x equals y? When my y equals 0, I can pretty quickly figure out what my x's are, correct? We call this finding our zeros. We've practiced it many times. So we know x plus 2 equals 0, x plus 4 equals 0, and by now you do all of that in your head. I know that you do. We know x is negative 2 and x is negative 4. And I found that by plugging in 0 for my y. So I know that this graph is going to cross at negative 2, 0 and negative 4, 0. So I can go to my graph at x equals negative 2 and x equals negative 4. And this has identified for me very quickly my X-intercepts. And I can immediately see them. You are at the point where I think you almost immediately see them. Question. Because when I ask you to graph a parabola, I want you to graph 5 points. And a lot of times when you're taking certain standardized tests, it's going to ask for the zeros. And the factored form gives it to you immediately. So it's just a really quick way to get 2 points on the graph. Okay? All right. Then the last form has an a out front, which is 1. So since my a is positive, I know my parabola opens up. So it also reveals to me the directionality of the end behaviors of my parabola. It also provides me with my vertex immediately, because what's happening here is if I zero out my quantity that's being squared, I find the smallest value that I can find to square. Because remember that 0 squared equals 0. Anything else I square is going to equal a positive number. Like, for example, if I do negative 5 squared, well, that gets positive really big. I mean, really quickly. If I do a positive 5 squared, it gets big really quickly. So with vertex form, when it's written like this, where it's x plus some quantity squared, what you do is you zero this out so that you can find your vertex, your minimum point or your maximum point. This is something we did with those other values, or those other things that we were graphing, if you recall. So what would zero that out? Negative 3. So if x equals negative 3, I can find the very smallest value, which would be at the very bottom of my parabola. So if I plug in a negative 3, I get a negative 3 plus 3 squared minus 1. And I think you can probably do this in your head. 0 squared minus 1 is negative 1. So when I plugged in a negative 3 to zero out my square, I got the vertex, which is here. So each one is using 0 in a different way. To recap, standard form you use 0 for x, and it reveals your y-intercept. Factored form, you plug in 0 for your y so that you can find your zeros or your x-intercepts. And in vertex form, you zero out your quantity that's being squared so that you can find your minimum point, or if it's upside down, your maximum point. So, and then I put little things down there at the bottom to remind you quickly of just a generic answer to those. Okay, so that's all of these. P.S. Look at that. There's my vertex. All of those fit along the same parabola because they're all the same equation in different forms. Okay, and one more thing. This was created from this. Vertex form comes from standard form when you complete the square. So if you can complete the square using standard form, complete the square, you can convert it to vertex form. It's pretty easy to do when your a is 1 and your b is an even number to complete the square to find your vertex. But when your A is something other than 1 or your B is odd, it becomes really clunky and it's just not a useful thing for us right now. Definitely in pre-calc you'll get a lot of practice at it. Okay, so now we have some other information. It says all of them had C and A in common. So we're filling in the blanks. All of those equations had an A in common. At the top, they all had an A in common. And so if A is greater than 0, or in other words, it's positive, we know immediately that our graph opens up. It's also a multiplier. Okay, so if it's a -2, it'll flip it upside down and then it'll stretch it really skinny. If it's a half, it'll stretch your parabola out really wide. So it'll do a couple things, but for right now we're just concerned with is whether it's greater than 0, positive, or it's less than 0, negative, and that it is going to flip your parabola upside down. So if A is positive, your vertex will be a minimum. If A is negative, your vertex will be a maximum. Okay? So that's always helpful information, and I'm pretty sure you already knew that, but we wanted to refresh your memory. Okay, so that's just what the basics of the different forms will do for you. Now I'm going to challenge you a bit. Let me open my problem here to these problems and scooch this up a little bit to right here. So the question is this, maybe. There we go. Can you see it? Yes? Okay. So the vertex of the parabola is crucial. You have to be able to identify it. So we're going to challenge you a little bit here. What's the most efficient way to find the vertex given each form? Well, this one is pretty immediate to find your vertex because it's written in vertex form, so it pretty much shows you the vertex. Whereas these two, you've got to do a bit of work to make it happen. So with standard form, I'm pretty sure you learned to find the vertex. You did the opposite of B over 2A. It's a formula. Write it down. And then you plugged it in for X to find your Y coordinate. And that is what you did when you were finding the vertex given standard form. I'm sure you all learned that last year. Okay? So, I'm going to move my little graph down a little bit here. All right. So, let's do that. So, let's plug it in. So, the opposite of 10 over 2 times -1, right? This is going to give me my X coordinate. So, I'm going to say X is equal to that. So, that's equal to -10 over -2. Which is in turn equal to 5. So that's my X coordinate in my vertex. And then to find my Y coordinate, I plug it in to the equation to find my Y. So the opposite of 5 squared plus 10 times 5 minus 21. You have a calculator, you plug that in so you don't make mistakes, you know. I'm going to go ahead and just give you the answer. The answer is 4 this time. So in this situation, your vertex is at 5, 4. Okay. So what was immediately revealed to you that we didn't talk about? So there's our vertex. What do we know about our parabola since our A is negative? A is -1, so we know our parabola goes like this. And what other point is immediately revealed to us? Your Y-intercept, which is 0, -21. So you now have 2 points that you can graph. And actually, you could even use your axis of symmetry and then reflect your Y-intercept, and then you have 3 points that you can graph if you wanted. So immediately revealing those 2 pieces of information and then using your formula to find your most crucial point, which is your vertex. Okay, so that's what happens in standard form. That's probably the most efficient way to get where you want to go. All right. The next one is intercept form. This one's a little bit trickier. Okay, intercept form. Well, remember what intercept form reveals. So in this one, our A is what? -1. So I know my parabola opens upside down since A is -1, so I know that. And then what other points does this immediately reveal to me? Your X-intercepts, right? So I'm going to go like that. So here's what I know, that if I make this equal 0, I can say x minus 3 equals 0 and x plus 5 equals 0, and I can find my zeros. That's real helpful information. I'm going to actually use it to find my vertex. So here I know x equals -3 and x equals, I'm sorry, that's a +3 and a -5. Okay, so that means I have 2 zeros. And if I'm just using logic here, and you don't have to graph this, I'm just going to write it so that I can explain how I'm going to find vertex from this. I know I have a point here at -5 and a point here at 3. And I also know that those are reflections of each other across the line of symmetry. So my vertex has to be somewhere in the middle, dead center between those 2 points. And since it's a negative, it's somewhere up here because this opens down. I also know visually that it's at -1. Here's how I know that. This is 4 spaces to the left, and this is 4 spaces to the right. Now here's how I know my vertex is going to cross x at -1. What I'm going to do is I'm going to add the 2 points and find their midpoint. I'm going to add them. And I'm going to find the midpoint between them, because the vertex has to be dead center between your zeros. So you know what that gives me? -2 over 2, which is -1. So that's part of my vertex. So I'm going to put it up here because I'm out of space. I know that in my vertex I'm going to get a -1 for my x, because it has to be dead center between my 2 zeros. Then you know what I do with it? I plug it in to find my y. So what I do? So I do the g of -1 is equal to the opposite of -1 minus 3 and -1 plus 5. And I plug it in. And it will provide for me the other coordinate in my vertex. So that gives me the opposite of -4 times 4, which is 16. And so there I have my vertex. Remember I told you it was way up there somewhere. -1, 16. So that provides you with your vertex as well. You use the midpoint between your zeros. That's not hard to find, because your zeros are evident, 3 and -5. So you add 3 plus -5, cut it in half, use that number, plug it into the equation, and you found your vertex. It'll go fast after you do it 1 or 2 times. Okay, I'm going to clear so I can get the very last one. Vertex form, my A is 2, right? So that means it opens up. And my vertex is evident right now. What x zeros this out? -5. And if this equals 0, doesn't this whole thing equal 0? So 0 minus 3 is -3. The vertex is looking right there at you. It's the opposite of h, k, that's it. Done. I love vertex form. Just slap that vertex on the graph, look at your multiplier, graph your equation. Okay, so I'm going to push pause on the video, but here's what I need you to know. Turn this off. So a couple other things to note. To find your x-intercepts, in other words, zeros or roots, your y has to be 0. Sometimes there will not be real roots. That's what happens when, like, for example, you have a parabola that maybe lives up here, or you're fine. I'm just going to finish the video. Or somewhere down here, it won't have real roots. When that happens, you'll have imaginary roots. To find your x-intercept, your y has to be 0. I'm sorry, to find your y-intercept, your x has to be 0. And there is always a y-intercept. Always a y-intercept. And you can see that on pretty much any parabola. At some point, this parabola, if I continue up, will cross the y-axis. They always have one. Okay? Other things to note, that parabolas are vertically symmetric. So whatever you graph on the left, you can reflect on the right. That's why your axis of symmetry is a good tool. The axis of symmetry passes vertically through the vertex. That's important. And for me, to graph an acceptable parabola, you have to graph at least 5 points and smooth, continuous curve with arrows on each end to indicate that the graph continues infinitely. So there you go. Probably that sound was awful at the end, but you'll figure it out. Have a good one.